Hi everyone, in this project I built a machine learning model to predict the probability that a borrower will default on a loan. This goal is to help lenders better evaluate credit risk while also considering explainability, fairness, and responsible AI practice. So for this analysis, I used Python. Pandas was used for data cleaning and preparation, while scikit-learn was used to build and evaluate the logistic regression model. The dataset contains borrower information such as income, row amount, housing, characteristics, and social indicators. The training dataset includes the target variable, which indicates whether a borrower defaulted, while the test dataset only contains input features. I also use the header field provided by the instructor to ensure the column names are correctly elegant. Uh, so the row CSV file contains some formatting inconsistencies. So I implemented a customer loader that reads only the rows that match the expected number of columns. After loading the data, I verified the structure and checked the data site shapes. Next, I cleaned the data set. Missing values were handled and the categorical variables were converted into consistent formats. I also ensured that the target variable contains only binary values representing default and non-default borrowers. So next, I created several simple features to improve predicted power. For example, I converted the borrower's age from days into years. I also created financial ratios such as credit to income and annuity to income. These ratios helps represent the financial burden of each borrower and are commonly used in credit risk modeling. The dataset was split into training and validation sets using an 80-20 split. And the sampling, stratified sampling was used to keep the same default proportion in both data sets. And since machine learning models require numerical inputs, categorical variables were converted into numerical values and then handle the missing value using medium imputation and standardized the features using a scalar. This helps the model train more efficiently. So next, I trained a logistic regression model with class balancing to adjust the imbalancing data set. And the model achieved a ROC AUC score of 0.76, which indicates good ability to distinguish between default and non-default borrowers. And because the data set is highly imbalanced, ROC to AUC and recall are more informative metrics than accuracy. A recall is approximately 0.73, meaning the model successfully identifies about 70% of actual defaulters. However, precision is relatively low at about 0.18, which indicates that many predicted defaulters are actually good borrowers. This trade-off is common in credit risk models because lenders often prefer to detect risky borrowers even if some safe applicants are incorrectly rejected. So the confusion metric provides more insight into the model's prediction errors. The model correctly identified the 67 default cases, but it also produced 308 false positives, meaning some reliable borrowers were classified as risky. This reflects the model's strategy of prioritizing the detection of high risk borrowers. And to understand how the model make makes prediction. I analyzed the most influential in futures. The most important variables include loan amount, housing characteristics, and social risk indicators. For example, AMT credit and AMT goods price reflect the financial scale of the loan, while variables related to housing conditions and social circles provide additional signals about borrower stability. These factors are consistent with common credit risk indicators used in financial institutions. And then I also evaluate fairness across gender groups. The demographic parity difference is approximately 0.18, and the equalized odds difference is about 0.20. And this means the model predicts default more frequently for male applicants compared to female. These differences may reflect underlying social patterns in the data, but they highlight the importance of the monitoring fairness while when deploying the credit models. So this model predicts long default risk, so predictions error have real consequence, and a false positive may deny credit to a person who would have repaid the loan, which can unfairly limit access to financial opportunities. A false negative may approve a loan for someone who later defaults, which creates financial risks for the lender. And in addition, the dataset may contain historical biases related to income, employment, housing condition, or social background. Therefore, this model should be used as decision support tool rather than fully automated decision system. So if deployed in production, the model should be continuously monitored. This includes monitoring data quality, checking performance metrics such as ROC, AUC, precision, recall, and calibration, and evaluating fairness metrics regularly. And the system should also detect the data drift and include human review for high impact lending decisions. So overall, this project demonstrates how machine learning can support the credit risk assessment while emphasizing transparency, fairness, and responsible deployment. And thank you for your listening.